Hello everyone, welcome to this channel. Today's tutorial is going to be on nomenclature of carboxylic acid. Kindly please subscribe and like and share to your friends so that when new videos and other organic molecules drop, you get notified and also advance your knowledge in organic chemistry. Let's get started. When we say carboxylic acid, we are making reference to a group of organic compounds, organic molecules having carboxylate functionality in them. We have this functionality, we term it as carboxylate functionality, and this functionality in every organic molecule turns that organic molecule to be a carboxylic acid. This is a functional group that distinguishes a particular molecule to be a carboxylic acid. So please, let's take note of that. In naming carboxylic acid, we do so by counting the number of carbons in them as we do so in alkanes. For example, in alkanes, if you have, let's say, a three-member chain, like this is an alkane, a three-member chain alkane, which we call propane. So we have a carboxylic acid having 3 carbons. With this one we call it propanoic acid. So it is very simple. In naming carboxylic acid, it's just like removing the final E of the corresponding alkane group and replacing it by IOC. So this one becomes alkanoic acid. So carboxylic acids are also called alkanoic acid because they are formed by just removing the final E of the corresponding alkane and replacing it by IOC, alkanoic acid. For example, we have something like hexane. Hexane is an alkane with 6-membered chain carbon. So its corresponding carboxylic acid is going to be hexanoic acid just by removing the final E. So removing this E and replacing it by IOC. That is the basis of naming carboxylic acid. We have situations whereby different groups occur on the parent chain. For example, when you have this group, and let's say one of this hydrogen is replaced by another group which we call, let's say, chlorine. This group is what we call as a substituent. When we take a parent chain and there is an attachment of a different group which is not basically part of the parent chain but has replaced one hydrogen, we call that group as a substituent. It can be any of the halogens or even an organic substituent like, let's say, methyl. When these groups also occur in a molecule, and in naming them, you address them by showing the position of that group in the naming. For example, in naming this molecule, the parent chain is 1, 2, 3, 4. So it's butanoic acid. What you do is you start numbering the carbon from where the functional group is. So in this one, the functional group is found is at the right side. So you start naming here 1, 2, 3, and 4. So you have 4 carbons and salt, butanoic acid. So butanoic acid, on the second carbon, one of the hydrogens has been replaced by chlorine. So in naming this, we show the position of the chlorine in the nomenclature. So it's going to be 2-chloro. butanoic acid. If let's say here was a methyl group, it is going to be 2-methyl butanoic acid. So it's very simple. In cases where two groups occur at the same position, let's assume we have on this carbon 3, let's say both hydrogens have been replaced by, let's say, bromine. You see, I rubbed the two hydrogens because this carbon can only take 4 bonds in all. So 1 bond here, 1 bond here, 1 bond here, 1 bond here. So that is it. So in this case, you are going to show the position of the bromine here. Both bromines are found on the 3rd carbon. So how is it going to be? Pause the video and try your hands on. The bromines are found on the 3rd carbon. So it's going to be 3, 3. So this 3, 3 show the individual positions of the two bromines. Dibromo, butanoic acid. 3,3-dibromo butanoic acid. Bear in mind, when we have consecutive figures in the naming, we split them by comma, and we split a number and an alphabet with hyphen. Take note. Let's say we have one bromine here. On this side, there is a chlorine. One of these hydrogens have been replaced by chlorine. So here you have a chlorine. The parent chain here becomes butanoic acid, as we know, as usual. But the name is the positions of the individual halogens or the substituent is going to be different. When counting, you count from here 1, 2, 3 as usual. The bromine is found on the 3rd carbon, whereas the chlorine is found on the 4th carbon. So in such situations, how are you going to do? In listing them, when you have multiples of substituent, in listing them in the naming, we do it in alphabetical order. So here you have bromine and chlorine. This is bromine and this chlorine. This is C and this is B. So in alphabetical order, the B must come first before the C. So this naming is going to be the bromine first on the 3rd carbon. So 3 bromo. Then the chlorine is found on the 4th carbon. 4 chloro. Then the parent name comes butanoic acid. So that is the basis of, basically the basis of the nomenclature of carboxylic acid. Please kindly subscribe to this channel, as in the subsequent videos you are going to know how we can name complex carboxylic acid. These ones are the basis, and you must get the basis before we move to the complex carboxylic acid. So please kindly like and subscribe and share to your friends so that you get notified. You are also going to look at the reactions of carboxylic acid and their derivatives like amides and the rest. So get notified by clicking on the subscribe button, clicking on the notification button, liking, commenting and sharing so that you get notified when we drop new video. Thank you very much for watching this video.